cloud formation. So clouds form when air rises and is cooled to its dew point as it's rising. The reason that this air is cooling as it goes up is because as you increase in altitude, you are decreasing in temperature. And that's something that we learned when we looked at our atmospheres, our atmospheric layers. So as you increase up in altitude, you go higher and higher and higher, you begin to decrease in your temperature. Because that air is decreasing in its temperature, it's condensing and getting smaller together, causing air to reach its dew point, and that is how you get clouds. We also looked when we talked about pressure systems that the only way you can get a cloud is through rising air, because that air is taking moisture along with it. And so if you don't have rising air, you cannot get a cloud, which again, just another review, is why low pressure typically has bad weather, because it has the rising air that will allow this cooling and condensing to create the clouds. A lot of times people will ask me, this is just kind of random, but they'll ask me, why is it that clouds look like one color in one place, and then if you go somewhere else from a different angle, they look a different color? If you're interested in cloud color, I do have a video on Canvas that you can go back and watch. But basically, it all has to do with perception. If you have a really big fluffy cloud in the distance, that like a giant fluffy white cloud, that probably is a storm cloud for the people who are closest to it. So the way you see it, the sunlight is hitting the cloud, making it look white and fluffy. But if you were under it, that cloud would be so dense and so high up, it wouldn't allow the sunlight to shine through, and that's why it would look darker. Typically, students are interested in that, so if you are, you can watch that video. There are a few types of clouds. You don't need to write this down, but the way we name our clouds is based on the form, meaning the shape of them, and then also the height. So how far up in the atmosphere are they forming? We're only going to look at 3 basic clouds that I'm sure you've already heard of before. So our first one is our cirrus clouds. These are high, white, and thin clouds. I always think of these because I think Cyrus, however you want to say it, kind of sounds like an older man. So I always picture an older man with his glasses. Let's see, there he is. And his name is Cyrus, and he has thin, white, wispy hair. And so that's how, because Cyrus means curl of hair. So that's how I've always remembered this one, just picturing an old man with the thin white wispy hair, also named that. So if you would like, I'm going to get rid of the drawing, but you're welcome to draw your own old man with wispy hair. Let's look at our other clouds. So then you have the cumulus clouds. These are your big fluffy rounded clouds. These are typically very pretty, but they also can be very bad because they can turn into a storm cloud. I remember when I was in Alabama for a family reunion. It actually happened to be the only family reunion we had, first and last, but that's a different story. Anyway, so we were at this family reunion, and it was very beautiful looking, and it was just bright blue skies, fluffy white clouds everywhere, and that night there was a tornado. And that's because with cumulus clouds, accumulate means like to pile up. Some of you, when you get home, maybe you just start changing clothes, and your clothes have a tendency to accumulate in a pile in your room, and that pile gets bigger and bigger and bigger as time goes on. Well, that's what happens with these clouds. Cumulus clouds will tend to grow. They accumulate on top of one another. And as these clouds continue to accumulate, if they get too big, they become what we call a cumulonimbus cloud. And those are your big storm clouds with severe storms and tornadoes. So if you do see a sky full of big white fluffy clouds in the summer, there's a good chance those clouds are going to turn, or not will, but could turn into a thunderstorm or some form of severe weather, whether that's over your area or over the area they are moving towards. And the last cloud we're going to look at is a stratus cloud. Stratus cloud is just like a layer of clouds in the sky. So if you look outside and it's just real gray and cloudy looking, those are probably your stratus clouds. And I remember these because stratus starts with the S, and sheet also starts with an S. So cirrus, the thin white wispy ones, cumulus, round and fluffy, and stratus are just the thin layers that cover the whole sky. And we actually do have one more cloud, and this is fog. So fog is a cloud, and it's a cloud with its base that is near or on the ground. if you've ever wondered what it would be like to walk through or fly through a cloud, well, if you've ever been outside when it was foggy, you have technically walked through a cloud. All that a cloud is water vapor. Clouds are actually really, really, really cold, but we can talk about that later. So it would be freezing cold if you were that high up and going through water vapor. But the ones that are at the ground, the temperature is a little bit lower, or warmer, I mean, and so you can just walk through those, and that's that. I put the what do you do if you drive through fog up because one day at work I was teaching this unit, and I was driving through fog, and I was at an intersection. And when I was at this intersection, it was a stop sign. I was looking both ways, and I couldn't see anything. So I decided to go, and then a car came out of nowhere, and thankfully didn't hit me because I was paying close attention, so I made sure I slammed on the brakes. But that car did not have its fog lights on. So cars do have fog lights. If you ever in fog, whenever you start driving, make sure you turn them on so that way you don't ever get in an accident and people can see you coming. But that's just my little random tidbit. So this is just a picture of some clouds. You got the stratus clouds down here, the thin gray ones. You've got your cumulus clouds, these little fluffy ones. And notice as they continue to accumulate or pile up, they become larger until they become this giant cumulonimbus cloud. And that is where you can get your tornadoes and whatnot. And then you have your old man with the wispy hair up here. So there's the old man. And so those are just some of your clouds. There's tons of clouds, but that's just the one we'll look at. So precipitation, this all comes from clouds. And again, don't write this down because it's not bolded. But for precipitation to form, the little water vapor droplets within a cloud have to increase in volume by roughly 1,000,000 times. So if you picture how small one teeny little drop of rain is, just imagine that's over 1,000,000 times larger than what it was when it was up in the cloud. So I just think that's interesting to think about. Two types of precipitation, the most common ones people are going to say is rain, sleet, hail, snow. But there is another one that we're going to talk about, and it starts with a G, and people typically never get this one. So I'll be interested if any of you know what it is. So let's take a look. So for precipitation, the precipitation that we get depends on the temperature of the lower few kilometers of the atmosphere. So km stands for kilometers or kilometers. Same thing, people just say it differently. Like I was telling you earlier, your clouds are very, very, very cold. So there could be times where you actually have ice or snow that is falling, but we get it as rain. Because if the lower few kilometers of the atmosphere is warm, it's going to melt any of that frozen water and just give it to us in a liquid form. There also are times where you will have snow that will fall, and then there will be a little warm patch within the atmosphere that will melt the snow, and then it will get colder again, some random little cold patch down, and that will refreeze it, and then you have sleet that is falling instead. So it all depends on the lower few kilometers on what type of precipitation you're actually going to get. So I'll give y'all one more second just in case you're still writing. I know at this time of the year, there's probably a good bit of you who are hoping that we get a snow day, or at least some early releases or 2-hour delays. Those are always my favorite because then you don't have to make them up. So who knows, maybe we'll get some of that weather soon. But moving on, here are the most common types of precipitation that you probably said. Rain, just drops of water. You all know what rain is. You see it all the time. Snow. Snow is fluffy and it's 6-sided ice crystals. So snow is actually very, very pretty. Some of you may cut snowflakes out on paper, or you've at least hopefully seen someone do that. Well, in real life, snowflakes do look like that. They are not just little pieces of white flakes. They are actual really pretty ice crystals. And it's really neat if you get to see that. I remember in kindergarten, we went outside because it was just barely snowing, and if you would get paper, like construction paper, and you sit outside for a second so the paper could get cold, and you catch your snowflakes, and when you caught them, you could see all the pretty crystal shapes they were. And we'll actually show a video to you to show you how these different snowflakes form. And then you have sleet. These are just small drops of clear ice. So sometimes the water will freeze in a way that gives you snowflakes. Sometimes the water freezes in a way it just gives you ice. And that really all depends. A snowflake forming is really more of a physics matter. So if you ever get really interested in physics, then that is something that you can look up. There's a bunch of stuff on the physics of snowflakes forming. Sleet is going to be more like you had snow and then it melted. And then once a snowflake melts, it'll never become a snowflake again. It's just kind of messed up. So then it just becomes a small drop of ice. And then, let's see. I thought I had a picture. I don't. Okay, and so then our last one, form of precipitation, this is the uncommon one. This is called glaze. So glaze is going to be when you have rain that is super cooled. Now, super cooled means that this water is below freezing, but it's not frozen. It's a really weird, interesting chemistry thing. But the temperature of the water is below freezing, but it's not actually frozen. Some of you may have seen little science experiments you can do where you super cool a bottle of water, and as soon as you hit the water bottle on the table, the whole thing instantly turns to ice. Or you can have super cooled water and you just put one little drop of an ice cube or something in it, and then boom, the whole thing turns into ice. It's very interesting. That's what's occurring with this rain. So basically, picture it being winter and it starts raining. And it's raindrops that are falling, but as soon as those raindrops make contact with anything, it forms a layer of ice around it. And you can see that with the picture. So you have some cherries over here, or some sort of berry. I guess, I don't know if they're cherries or not. And then you have this bottom picture of a stem where the ice has surrounded it. Because since it's liquid water, when it first hits, that liquid drop goes all the way around the object, and then it freezes. And it's very, very pretty, but it's also very, very dangerous. If you can imagine a tree that it's just raining and raining and raining, and it's being covered in all this water that's turning into ice, the whole thing is surrounded by ice, and that becomes very heavy. So it won't take that much more precipitation for all those limbs to start breaking. We had 2 winters when I was growing up back home, because I'm from a little bit more northwest of here, where we had ice storms because of glaze. And the neighborhood I lived in, it had a lot of trees, and I remember watching those trees fall. We were without power. I don't know, there were a lot of days we didn't have power because trees kept falling. One time I was looking at my neighbor's house, and I heard a loud crackling noise, and I looked over and I watched this giant oak tree fall on her house. She was okay, but it completely crushed one side of her house. Next winter, we had another ice storm, and that poor older woman had just fixed her home, and another tree fell on the same side as the house as it did the year before. Very unfortunate, but again, she was okay, so big picture, things were all right. But that is glaze, and it's just very interesting if you ever want to look into that a little bit more. So next we're going to look at hail, and then there's going to be a couple videos that I'm going to have shown to you so you can just learn a little bit more about it. So when we were looking at the other types of precipitation, sleet and snow, what season do we get those in? Winter. Well, we don't get hail in the winter, or if you do, it's very rare. It hails in the summer. So this is a type of frozen precipitation that occurs in the summer. And that always messes with people's minds, but I'm going to tell you about why. You typically get hail when you have a very big storm. They are associated with severe thunderstorms and with tornadoes. And that all has to do with something that we call a warm updraft. So warm air rises because it's less dense. Well, the more air that you have rising and the higher up that air goes, the bigger the cloud it can make. And so in the summer, sometimes you have such warm air that's holding so much moisture that as it goes up into the atmosphere and it goes really high in the atmosphere, it creates these giant cumulonimbus clouds, creating big storms and tornadoes. And that is when you get hail. And so I'm going to go to the next slide to show you a picture so I can describe how the hail is actually made. I did want to bring your attention to some of the pictures on this one. So that top one, those are, I don't know, they look like snowballs, but those are some pretty large hailstones, and you can see the damage that it does to a windshield. I know in Greenville we've had like pea-sized hail and stuff like that, and that doesn't do much damage, but that type of stuff, that would. And then look at that bottom picture. That hailstone is 8 inches in diameter and 18.6 inches in circumference, and it weighs almost 2 pounds. Now, if you went outside and that thing fell on your head, you're going to be really, really hurt. So if it's ever a big hailstorm, just stay inside. So let's look at how hailstones are formed. This is your big cumulonimbus cloud. Now notice you have the warm updraft, and that's with your red arrows. So it's a hot summer day, very, very humid. Conditions are just right, so you have a warm updraft, and this is key. This warm air shoots way up into the cloud. And as it does this, now like I told you earlier, clouds are very cold. So there's actually little bits of frozen ice within these clouds. And so what your warm updraft is doing is it's getting one of those little pieces of ice or a super cooled thing of water, and it's making it go up into the cloud where it freezes, and then that into a little tiny ice stone, and then that little tiny ball of ice will start to fall down. Now, if the updraft is strong enough, then it will hit that little ball of ice, then shoot it right back up into the cloud. And as that little ball of ice shoots back up into the cloud, it gets another layer of super cooled water that turns into ice around it. And so that little teeny tiny thing of ice is now bigger. And so it's now like a marble size. So the little marble piece of ice starts to fall down, and then boom, an updraft hits it and shoots it back up into the cloud, where again it gets another layer, and then another and another, because as long as your updrafts are hitting those balls of ice and making them shoot back into the cloud, they keep adding more ice onto them and getting larger and larger and larger. The moment this updraft is not strong enough to make the ice go back up into the cloud, the ice becomes too heavy and it falls to the ground, and that's when you get hail. So the larger the hailstone, the stronger the updraft was, because that means that updraft could take that little ball of ice that turned into a larger and larger and larger ball and keep moving it up into the cloud. So when you are looking at the ice there, the hailstone that was down here, that had to be an extremely strong storm to make something that big. Because that means just the rising air, it was rising at such a pace, it could pick up something that was 2 pounds and keep it into the cloud before it finally decided to fall. You're not going to get storms like that or hail like that unless you live out west in the like Tornado Alley. But notice you have the hailstones where the warm up draft is and where the cold down draft is, because cold air sinks. You have rain because you don't have the warm draft shooting up those little things of ice back into the cloud. So that's hail, and if you are still confused or interested in how that forms, you can always watch the video that's in green when you go to Canvas. And those are just a couple more pictures of hail. So you have these little like pea-sized ones. This is what I've seen in Greenville before, and those are kind of interesting. You've got the more golf ball sized hailstones, and then this is pretty large. Let's see, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are about 8 inches wide if you were going to look at these stones. But notice these hailstones just look like a bunch of the pea-sized hail put together. And that's because every time the updraft shot it up, it was combining those things. So there's just a couple more pictures. And let's see. So before we get to chunk 2 of your study guide, I have a couple of cool videos I want to show you. One of them has to do with how a snowflake forms and shows you an actual picture of real snowflakes that a photographer took. And then the other one is just some video I saw on YouTube that shows just like big hailstorms that I thought you may enjoy watching. So I'll go ahead and let you end this video while you watch those the weather videos. And once you've watched the weather videos, we will move on to chunk 2 of your study guide. Have a great rest of the class.